Good morning, students. Now we go for the second chapter. How can we solve exponential equations? Well, first we have to know what exponential equations are. So we're gonna make sure we understand that first. So exponential equations are equations that have a base, an exponent, and that equals some number. But more than that, exponential equations happens when the variable that we want to solve for, it's on the exponent. Okay, so let's put an example of an exponential equation. So let's put 2 to the third equals 2 to the x. Okay, as you can see in this example, the exponent, sorry, the variable that we want to solve for isn't the exponent, it's up here. Okay, there's kind of three types of exponentials we want to solve. The first type, it's when the bases are the same. Okay, see the base here, Mick, how much is the base? How much is the base in here? Okay, well, let me see. Isn't it 2? Yes, Mick, great. So the base is 2 in this side, and in the other side, Mick, also 2. Yes, also 2 on the other side, right? When that happens, exponentials are really easy to solve. What we're gonna do, we're gonna make the exponents equal. So this here, this 3 and this x, we're gonna set here a new equation. Okay, so we're gonna have x equals 3, and that's it. Okay, we are done for x equals 3. Should I make another example, a more difficult one? Yes, please. Okay, let's suppose that I have 10 to the x equals 10 to the, no, x, let's say x minus 5 equals 10 to the third. That's a more difficult one. Now we proceed the same way. We make this equal. Now we're gonna have x minus 5 equals 3. We have to add 5 both sides. So the plus 5 minus 5, this cancels out, and I have 3 plus 5, so it's like this 5 goes to the other side adding, so we're gonna have 5 plus 3, which is 8, right? That's an easy one. Okay, but sometimes what it happens sometimes is that exponential equations might not have the same base. Okay, imagine that I have, for example, 4x minus 2 equals 16 to the power of 3x. Okay, imagine that. So let's see what happens now. Is the base the same both sides, Mick? No, it's not, right? In this side we have 4, and on the other one we have 16. Yes, but can we express 16 as a base of 4? If we can, we just rewrite this equation. Okay, 4x minus 2, and then instead of writing 16, what is 16 expressed as a base 4? It's gonna be 4 squared. 4 squared 16. 4 times 4 is 16, right? So now all this is this. Now I have to do 3 to the x. So this to the power of 3 to the x. Okay. Now we have a power to a power, right? A power to a power. Now, a power, if we know the rule, and we have to make sure we do know the rule, a power to a power, okay, x to the a to the power of b. What we do with the exponents, we just multiply exponents. A times b, that's what we do, okay? So if we have x to the second to the third, we're multiplying 6. 6 times 3 is x to the 6, okay? So right now, what we're doing here is 4x minus 2 equals 4, and then 2 times 3x, a power to a power, we multiply exponents, so it's 6x, okay? And now we're in the same position as we were here. What we have to do is we just have to make the exponents equal. So what we're doing is x minus 2 equals 6x, right? The way we solve this is I'm gonna actually subtract x on both sides. So it's like moving this x to the side. So we're gonna have negative 2. We keep this negative here because it's part of the 2. And then we just, when we subtract the x in this side, what it's gonna happen, it's gonna be 5x, right? And then last thing, we have to get rid of this 5. To get rid of this 5, we need to divide both sides over 5. Oh my God, over 5. And so this 5 is going dividing to the other side, and we have negative 2 over 5, right? We're done with this example. Now the last example I'm gonna write it here. It's when it's impossible to make this bases equal. Like imagine I tell you 2 to the x equals 10, right? 2 to the x equals 10. If we think about it, it's impossible to express this as a base of 2 because actually 10, it's 5 times 2. That's what it's inside 10, right? So, and if we think 2 to the 0, how much is 2 to the 0? Make 1. Yes, 2 to the 0 is 1. Anything to the power of 0 is 1. So then 2 to the first power is 2. 2 to the third power is 8. And then 2 to the fourth power is 16. So as we can see, the 10 is in between the 8 and the 16. So actually, it must be 2 to the a little bit more than 3 to make it 10, right? How are we going to do this? So the way we solve this is we use what we call logarithms. Actually, a while ago, it used to be a paper with some tables, and when you needed to solve this type of equations, you just would look at those tables where you had the logarithms already computed for you. So it doesn't take that long. Nowadays, no, it's even easier. We can use calculators for that. So actually, let's see how to convert this to a log so we can use the calculator to solve it, okay? So first of all, we need to know how to convert from an exponential to a log equation. So it looks a little bit difficult at first, but believe me, it's really easy. You see here the power, the exponent. You see the exponent, the exponent will go here. Now do you see here the base? It's the base of the log also. Logs have base, same way as exponentials. Okay, so the base will this is a notation thing. So you just learn it and that's it. So this is the base, and then whatever we have on the other side, it's gonna go in front of the log. Okay, so let's try it. So here the base is 2. The exponent x, then y will be 10, right? So what we're gonna do, we're gonna just rewrite it. We're gonna rewrite x equals log base 2 of 10. And after that, we just use the calculator. Take the calculator, and this more complex calculator, they can do a log of any base. So we turn on the calculator, and we're gonna do alpha f2 number 5, which is log base. And then the base is 2, the log is 10. So for this particular case, the answer is 3.32. Okay, and now I'm done. The next video, we're gonna do more difficult more difficult exponential equations. Okay, great.